So, we were talking about the Carnot cycle. So let's look at the Carnot cycle on a diagram, shall we? Let's see if we can draw this out. I'll set this beside me here, and let's just start with a new sheet. See if we can get all that in there. Like I said earlier, I'm sorry, the sun is moving. Another few minutes here, it may not be on the paper at all, but it's still showing us it's there right now. Okay, so Carnot cycle, if we look at this, I'm going to draw it here. Okay, so if we draw, I'm going to use pencil here because I'm going to erase some stuff here in just a little bit. So Carnot cycle. Okay. If I draw this on a PV diagram, pressure on the y-axis, volume on the x-axis. Right, and so isothermal expansion. Can you see that? Yeah, so isothermal expansion. That's from state 1 to 2. So we're going to be at this high temperature. So line of constant temperature coming across like this. As this is state 1 and this is state 2, we're going to go and we're going to expand. We're going to go from a smaller to a larger volume. Right? Now recall that, of course, work out is the integral of pressure with respect to volume, right? And so what we're saying here is that all of this area here is potential work that this engine could extract from the system. All right, so again, expansion. We're going to go from high to, we're going to increase the volume from state 1 to state 2 along a constant line of temperature. This is where most of the work in the engine can come from, most potential work. Then we've got an adiabatic expansion. Now, if I expand the system, continue to expand it, but I do so in an adiabatic fashion. Well, if I don't allow it to lose heat, if I don't allow it to lose heat and I expand it, if you think about PV is equal to RT, you increase the volume, something else is going to have to change. Well, what ends up happening is the temperature will drop as well as the pressure. Both the pressure and the temperature will drop to this lower temperature. And so potentially all of this additional area here is potentially work that we could extract out from this engine. Now, to get this to repeat over and over again, I've got to get back up to 1 here. Okay? Well, to do that, I'm going to have to compress it, and I'm going to have to also increase the pressure. Well, what Carnot suggested is let's do an isothermal compression. To get to state 4, he says do an isothermal compression to get back to this 4th state. Now, to do that, I've had to put work in. Remember, compression is work in. So now, if this area under here was all positive, I'm now adding a negative area to it. So this is now all removed. And there's work that we've had to put into the system to get it back to a lower volume, to compress it. It doesn't do that spontaneously. And then, to get it up here, back to the initial state, I've got to put in additional work. I've got to increase the pressure and compress it just a little bit more. And that's what, so here I've got what we call isothermal compression. Here I've got what we call adiabatic compression. And I'm going to have to stop there. I'm being called away real quick. I'll be back in just a moment. But that is the Carnot cycle.